This is your host Swapnil Bhartiya and welcome to TFiR Newsroom. And today we have with us once again Liran Haimovitch, CTO and Co-Founder of Rookout. Liran, it's great to have you on the show.
Hey Swapnil, it's great being here.
Right, it's a pleasure. You folks are announcing a new serverless debugging experience. So tell us a bit about what exactly is it?
Rookout has had some basic serverless debugging capabilities from early on. Rookout has always been about debugging anything, anywhere, wherever it's running. And so as soon as serverless came out, it was important for us to have some basic capabilities for serverless debugging, because we've been hearing from our customers how hard it can be to debug serverless applications, especially because they're event-driven, because they're very reactive in nature, because it's very hard to set up development and staging environment when everything is happening on AWS, and it's very hard to simulate it locally. But after a while, we've understood that it's important to take serverless as a whole as part of the debugging paradigm. It's not just about being able to debug one instance of a function, especially as we're seeing more and more customers shifting from serverless, from experimental one-off function for DevOps or pipelining into major stuff, huge pipelines, thousands of functions, billions of invocations. And you need something that provides a more holistic experience, something that allows you to see all of your functions, see all of your code, see all of the events, see how everything combines together so that you can actually drill down to that specific instance, that specific invocation where the bug you care about is happening, so that you can focus on that, debug that, and troubleshoot whatever is bothering you.
Can you also explain how this new serverless debugging experience is different from debugging code running on more traditional infrastructure?
So there are quite a few things. First and foremost, traditionally servers are up. That's why they're called servers. You have the servers, you spin them up at some point, whether when you're deploying or when you're scaling, and you have those servers, and you're going to have 1, 10, some of our customers have 3,000 servers, but you have those servers and they're running for the long term. Serverless, on the other hand, those servers are coming and going as they see fit. So if you're going to connect right now and see how many functions are running or how many servers you have, that might change 3 minutes from now. That might change an hour from now. It might be very different from what happened an hour ago. And so it's not just about looking what's running right now. You want to see what has been running. You want to be able to predict what's going to run. You want to be able to ask questions about that, such as what versions are deployed. And so it's not just about looking at the servers that are running. It's also about looking at whatever is deployed, looking at whatever was running or whatever is going to run. It's about being able to do so in a very reactive manner, because you can't attach to something if it's not there. Now, I've recently heard that the median time for a Lambda is under 60 milliseconds. So think about that. Within 60 milliseconds, you want to see a Lambda function start, you want to attach to it, you want to decide what data you want to collect. Now that the function is running, and then you want to detach, let the function returns its value, and still get all the data you've collected for the debugging. Obviously, this is not something that a human can do, but even a machine or a system or a process has to be optimized to do that in a very clear and efficient and easy to use manner.
Excellent. Thank you so much for explaining that. Now, if I'm not wrong, you also announced a debugging experience for Kubernetes earlier, and now it's for serverless. It seems more or less like, that you folks kind of opinion that, different technologies may need their own UI and UX for debugging. Is that true? Because we kind of live in a world where we are trying to simplify things for developers, where they can see everything on the same, they say, a single glass of paint,
So we've been focusing a lot on that single pane of glass. It's part of our cloud native debugging experience. The original phase, the first phase of the cloud native debugging experience, has been focused on Kubernetes, and we've seen huge impact on that. Every customer, we've shown that, whether it's a demo or we've rolled them out their account, provided awesome feedback about how useful it was, how much it improved the experience. Because at the end of the day, as an engineer, you have all this code running, your code, other team members' code. This code is running in production, it's running in staging, it's running across dozens of microservices. And you need something to help you make sense of where exactly you want to focus and what's going on. And this is what our original Kubernetes cloud native debugging experience was about. It's around taking that core capability of debugging and tying a great experience around it for Kubernetes. And what we've seen is that experience, while improving things greatly for Kubernetes, wasn't optimized for serverless, wasn't optimized because serverless in a way is 100x. Everything you would say about Kubernetes, scaling up or down, concurrency, distribution, all of that, serverless is 100x. You can spin up 100x faster, you can scale down 100x faster, you have functions that are not running at all. And we wanted to take that extra step because while the core of our user base is Kubernetes, and I think about 70% of our customers, even more, are using Kubernetes today, we're seeing a growing segment that's using serverless, that are asking us for better support. And we wanted to give this new experience to them as well in a way that's optimized for that. I would mention though that today, if you're looking at the two big paradigms in cloud computing, you have containers, you have serverless. It's not as if you have 50 different ways of doing cloud native. So we feel comfortable aligning with those key flows and optimizing for them.
Once again, very well explained. Thank you. And this, the next question is going to be a bit tricky and depends on how you look at it, because and it's a debate which has been going on for a while, where I want to understand how do you see debugging versus observability? They, in one way they look at things differently. One is when system is running versus one, debugging is when you stop things. So how do you look at it? And at the same time, when you do see a lot of movement is happening within the industry, do they play different roles or they're coming closer?
I think the two terms are very complementary. Now, if you take observability, at its core, observability is about being able to determine the inner state of the system, determining what's going on within a system by looking at its inputs and outputs. Now, those outputs traditionally are the three pillars of observability. They are metrics, traces, and logs. Now, today, those metrics, those pillars, those outputs are always static. You predefine them as part of the application code, as part of your observability stack, and then you have to live with them. As everything is going wrong, as something is happening, you have to use whatever outputs you have pre-decided on to figure out what's going on. And that's kind of where we at Rookout believe dynamic observability comes into play. We're big believers in observability, but it's incredibly hard, I would claim impossible, to build a system that provides you all the outputs you would need to answer all the questions when you would need them, every possible question, and especially do it in an economically reasonable manner. So dynamic observability allows you to adapt those three pillars of observability, logs, metrics, and traces in real time, so that when new questions come up, you can get new data to answer those questions instantly and easily. So that's on observability. Debugging is actually a term that can mean one of two things. The first is figuring out what's wrong, identifying and removing a bug, which if you look at it that way, it doesn't really matter which tool you're using. You can use observability, you can use a debugger, you can use anything at all. You can use logs. I mean, you're just removing a bug and you can do it in literally more than once. It happened to me. I was about to go to bed and then I had a aha moment. I figure out from my memory, from my knowledge, whatever, something is wrong. This is how we need to fix it. And that's also a form of debugging. On the other hand, the other form of debugging is about operating a debugger. Now, operating a debugger is something you would do for removing bugs, but it's also something you would do for many other purposes. You can do it for training to see how the code is flowing. You can do it to become more familiar with a library or a framework or a runtime. You can do it as part of a design sprint. You can do it as you're designing new code. You want to learn more about the code. You can want to learn whether a function is being called and what outputs or inputs are being used within that function so that you can better design it, better plan it, and better think through new features and bug fixes you're working on. And in that case, it doesn't really matter why you're using the debugger. You're just using it to get that inside data, unlike the outside data, the external outputs you're using for observability. You're using a debugger or a production grade debugger such as Rookout to get internal data, to get the inner state of the system, to accomplish something, to do your job better. And that's kind of how we see those two terms. They have a lot in common. They're often used together, but they're also independent of each other. For instance, if you're just using observability for monitoring, for knowing something is wrong, then it doesn't have that much to do with debugging.
One more thing that I want to ask you is that as you are bringing these debugging, experiences, how do you suggest developers kind of maintain a balance when it comes to debugging from their own IDE that they prefer versus, your web apps? Because, developers can be opinionated. They want to work in their own comfort zone.
IDEs, for the most part, are what we use when we're in very hands-on, creative mode. When we write code, when we're running it locally with very short feedback loops, and it's awesome, an IDE is there. You have your scratchpad, which is whatever you've checked out on Git. You're editing that, you're experimenting with that. You're instantly rebuilding, redeploying locally, running the stuff. You're debugging, walking through the code, stepping through the code. Everything is awesome. But from that mode, you often move to the operational or observational role, whether it's using your CLI to use Helm or Terraform, whatever, to deploy, whether you're committing into a CI system, you're committing to your Git repository, going through your CI/CD system, which is probably web-based today. That's where most CI/CD systems reside. Whether it's about observing the logs, which you would probably do in your CloudWatch or in your observability platform. And in all of those cases, when you are more in the observational mode, in the operational mode, you're probably spending much more time in your CLI or in your web than you are in the code. And in fact, what's happening on your machine, which is where the IDE lives, where your IDE excels, doesn't really matter anymore, because even if you're going to edit something locally, that's not going to affect what's happening in your Git. That's not going to affect what's happening in your staging environment in the cloud. And so once you're moving there, you're probably better off using more read-only tools that are better focused on showing you what's going on, allowing you to observe it and learn from it, which is I would say, the family of tools where Rookout is.
Liran, thank you so much for taking time out today and not only talk about this new offering, but also kind of help us understand the difference between observability and debugging. Thanks for those insights. And as usual, I would love to have you back on the show. Thank you.
Thank you. It's been a pleasure.